Okay, so we have a review problem request about DCI, Daily Caloric Index. So, first, it's based on the BMR. So if you're not getting your BMR, you can't get the DCI. Are you getting your BMR okay?
Yes.
You are, okay. I'm going to pretend you're not, just because it's a review problem and not everyone is here today. Should we do Arthur or Odette for our review problem? Odette, we did Arthur in class last time. Okay. That is our first slide. Okay, I won't go too slow and careful because no one really asked for this, but just in case someone wants this because they're not here today, or maybe in week 10 when you're studying for the final, this will have left your brain, then here's one more. So Odette is a 30-year-old, very active woman who weighs 110 pounds and is 5 foot 1 inches tall. What is her BMR? So lots of stuff there. What's the, at this point, red herring? What information do we not care about for this formula?
We don't care that she's 5'1".
We do, because we need her height right there.
Her age.
Age goes there. Her name? What I'm looking for is the very active. We will use that later, but we don't need that now. The BMR is her basal baseline metabolic rate. If she just lies in bed all day because she's in the hospital having a terrible thing happening. So the fact that she's normally very active doesn't matter. This is when she is being a couch potato. But the numbers we all need. We can plug 30 into the age. We can plug 110 into the weight. 5'11", that's not friendly. Yes. So 5 times 12, because each of those feet is 12 inches. Come on, make little lines. And then we had 1 inch that was already there. So now we're ready to go. We've gotten rid of the thing that we can ignore. We've turned the unfriendly number into something we can plug it into the formula. Okay, now the other thing, we care about her name a little bit, just because we need to know it's a her, and if there weren't any other pronouns. Okay, so we need to know it's the woman's BMR, but it says her, it has Odette, we're good at that. So we want weight times 4.55 plus height times 15.88. I don't know why I'm doing multiplication with an X instead of a dot today. Tell me if that messes you up. Minus 30 times 5, and then plus another 5. Okay. Yeah. Yeah.
So it's plus 5 for a woman and subtract 161 for a man.
Yep. Okay. Is the plugging in step okay?
Yes.
Okay. So then, now it's just time for the calculator to earn itself. All these parentheses I don't actually need. The multiplication is going to happen before the addition and subtraction, just because of order of operations. So I don't have to put them into the calculator. They're only there to help my eyes understand that, yes, there's 3 different things happening for 3 different measurements. It kind of looks nicer that way. But when I'm typing it, I can be lazy and leave them out on the calculator. So 110 times 4.55 plus 61 times 15.88 minus 30 times 5 plus 5. And they get 1,324.18. So that's overly confident. There's no way we know how many calories her body naturally metabolizes each day to the 100th of a calorie. This is just that the numbers did that. So if you want to round it, then a common thing would just be to get rid of the decimal point. But even that, we're not that accurate. These formulas are good to about 10% maybe. Right? So if you wanted to round it to 1,320, you could. I'm just going to leave it like this. But realize we're bragging a little bit here. We don't really know it this well. Okay, so that was our BMR review. Now let's get to the DCI that you actually asked about. So she burns energy for these reasons too. That her activity is making her burn more energy, and the actual burning up of food and metabolizing it takes energy too. And those are smaller than the BMR. We're not going to double this number usually, sometimes. So we're going to take the BMR and multiply it by some scale factor. It's going to get bigger. We want it to get bigger so the thing we multiply it by is larger than 1. Only one of these numbers, the very active men, will make it double the size. Everything else is between where it is and double, 1 point something. So now we needed to know that Odette was very active. So we can say, here is the number for a very active woman, 1.82. It's like playing Battleship. Go across for woman, go down for very active, pick the number.
So we're timesing the BMR times the scale factor, which is 1.82.
Yes. So, let me just grab the problem number.
I'm sorry, I had to take
That's okay. I will keep moving.
Exactly who they define very active. Because I ran like 5 times this last week. But then I sat on
You're
my butt the last
thinking
2
too
days.
much. This is the World Health Organization helping people make an estimate. So if you self-identify as very active instead of average, then that's probably good enough. But obviously in real life, there's more than 3 levels of activity for people. So this is just sort of something to...
I used to use the weights a lot, and they have things that you exercise this many days or this hard for this intensity kind of thing. So if you read it, if you're interested, look it up, and it'll tell you if you exert yourself for this long, for this many days, you're very active or active.
Right. Well, I'm at the highest, the scale factor because I run. So I was figuring out all this.
Why are my numbers dropping?
Does it matter what you eat?
I don't even know. That's an issue. But that's one of our big problems that we can do, right? Where we figure it all out for ourselves. Because that's what I've been doing. I just haven't figured out what calorie intake yet.
Yeah, let's look at that homework assignment. We can advertise it. It's good to do. So the homework assignment is to do these numbers for yourself. Then we saw the guidelines. You had 2,000 or 2,500 as your number for DCI. You contribute this much according to the USDA of protein fat, and carbs. So if your DCI is not exactly this or close to it, then fidget somehow. We saw the example of Arthur, who was right in the middle, so we just averaged the two versions of the USDA guidelines. Then, once you have those, regardless of if you trust them or not, because everyone has different opinions on diet, but we're in a math class, so keep doing the math. Keep track of what you eat just for a day. No one will know if you're exaggerating or fudging. And see how well it matches. And then there was the interlude from Factfulness about don't just think of good and bad calories, but avoid that gap instinct, having 4 calories of how healthy something is. So sort the foods you eat into those categories and see how you do. For any of these, if it says you, it could be somebody else, right? If your parent or spouse or roommate is more interested in this than you are, then do it with their numbers. I just had my annual physical today. So, number 2, as long as we're reading these in class, the BMI and body fat formulas we don't use because there aren't any that are great for individuals. They have their uses for demographic data, analyzing large populations, but for individuals, they're problematic. But the doctor's office uses them anyway. I was told mine this morning at the doctor's office. So look at that history a little more. And that's not necessarily a math problem per se. There's not going to be any numbers you're crunching here, but that's a good thing to know about, especially if you're here because you're going into nursing.
They told you your body fat formula? Or your body fat at the
Not the
doctor's
body
office?
fat, just the
BMI. Oh, what's your BMI?
Mine 25.2.
Oh.
And as long as we're doing that, let's go here and so I had said that the pictures looking at your abdomen and love handles are probably just as accurate, if not more, than the formulas people have. So at 25.2, whoops, I'm done at body fat, so then that's just, I don't have the border lines here. Basically 25, so I'm just over borderline of what should be healthy. And I'm not going to take my shirt off in the math class, but if I were to do, then you would see that, yeah, I'm kind of borderline between barely love handles and noticeable love handles, right? So for me, at least, the number is moderately accurate. But since I sort of look average shape, then the fact that a number about averages of people is accurate isn't as surprising. It's not.
Okay, can I ask a question?
Sure.
Okay, so the scale factor for
So her scale factor was 1.82.
the DCI,
So we multiplied and got a bigger number.
now, and that, the scale factor can be found with the review homework,
Yes.
right?
And I don't think it shows up on the practice tests, so you'll have to have it in your notes.
Okay, all right. Thank you.
Remember that anytime you're wondering, you can go to a practice test and just look at it and see, is this the kind of number that's given in the test? Is this the kind of thing that's not? So you don't have to write down all the amortization table that's given to you. When we're scaling food, then the yield percents will always be given to you because we're using random fake food from the World of Warcraft instead of real food. And so on like that. But use your practice tests to help you know how much you need to put in your notes. Some people will put more in their notes just because for them that makes everything nice and
And you said that the DCI needs to be in our notes because it's not in there anymore?
right. So these 6 numbers, whoops, now I'm looking at homework. These 6 numbers here you need to have in your notes. This DCI scale factor table. too big. I wish I... Should I fix the blue? Is it as bad for you as it looks for me?
Yeah.
Yeah. On the screen, it's so much better than on the projector.
But I'm blind, so. Thank you.
You're welcome.
Everyone.
It's easy for me to change. I should do that. Oh, everyone know what cascading style sheets are?
Sure.
A lot.
Okay. And anyone know that you can do Control-U on your web browser and see the code behind it? Okay, you don't care. Anyway, so I have a command at the top that this file is a cascading style sheet that's being loaded by all of my pages. And if I were to go there, then it has all this formatting code about how big and what color and so on everything is. So I don't have to make every page have a copy of this. If I want to change all of my certain kind of block quotes from dark blue to light blue, I just change it once, and all the pages load.
So you just click Control U,
Mhm.
and it shows you all the code for the entire page.
Yeah. Oh, okay. There's used to be, I have no idea, I haven't checked in years because I've been busy, but there used to be a cute website called Learn to Hack, where it would just teach you how to look at websites and take advantage of things that people that didn't know how to build websites would not do well. Anyway, okay, back to math. Other review problems. Should we do another DCI one, or are we done with that?
I think I've got it.
You got it? Oh,
Yeah. That was just the part that I had missed. Thank you so much.
you're welcome. Should we do some Math 20 review? Yes, okay. Edwin's been jumping at the chance to come up here, so let's... Okay, any of these we want to do?
I don't like factors. I remember how to do them now, but I always forget. So, yeah, greatest common factor. So,
Wait, you want us to come up and do one of those?
So do we divide 9.6 into 637 divided by 9.6?
For number 7, let's do number 7. This is exactly the same kind of thing as we talked about with scaling the recipes. If you did this kind of problem often, you'd have a very good intuition of when to divide and when to multiply. But most people don't do this kind of problem that much in daily life, and especially when we take our test, our brain shuts down. So that's why we did the proportions as much as we did, because that's the completely fail-safe way to get these right. So how did the proportions work? First I write the skeleton of my proportion, fraction bar equals fraction bar. Then I say one situation is going on the left, the other situation is going on the right. So situation, you don't actually have to write this, of course, but situation number 1 and situation number 2. So what is the first situation? It is 76 miles on 9.6 gallons. And at this point, if I am wise and cautious, I'm going to stop reading the problem. I know that the words have to be matching. They have to be parallel. If it says miles on top on one side, it has to say miles on top on the other. If it says gallons on the bottom on one side, it has to say gallons on the bottom of the other to match. So I will just stop reading the word problem finish making my setup, and then go back and keep reading. At this rate, how many gallons, well, so that's the one I don't know, are used by a 637-mile trip? If for some reason you put the gallons on top both times, that would be fine. All the cross-multiplying will make the same answer. So I really can't mess up so far, right? All I'm doing is organizing the things into these four corners. And as long as I'm careful and say that the words match top and bottom, then that's what keeps me fail-safe. Okay, now I do my multiplying. I mentioned before that I'm always going to pick the side with the y to go on the left and put the y first, just because that's what my brain happens to like. You can do something else if you want. And that doesn't look like a decimal. I need to make that better. Oh, okay. It's going to let me make multiplying dots. Not really. So I've done my cross multiplying. So y times 76 is whatever that is. 9.6 times 637. I have something stuck onto y with multiply by 76. So to get y by itself, I have to do the opposite. And I get this long decimal. Once again, I don't know anything to this accuracy. We're talking about cars and mileage and stuff, right? It has lots of decimal points just because there's a math formula, not because I really know that. So I should round it. And how many gallons? I'll just say 80 gallons.
You don't need to round up since it's a real thing in the real world. Like because it's more than a gallon. It's not that like that on the test. Okay.
If I was actually shopping, I wouldn't stop my car when it has less than a full tank anyway, right?
I
So
wouldn't get
we're not going to cause any disasters. Okay, I want to talk more about cross-multiplying, since we happen to do that. There's a shortcut. It could be that when you look at this problem, what you want to do is you say, I have a number by itself. I have a letter by itself over there. So I know I'm going to multiply by the two that are the other diagonal and then divide by the value that's that one. Have people seen that shortcut? Yeah, okay. So is that a good shortcut? And the answer is, if you're not going into Math 60, that shortcut is great. It's never going to mess you up. It'll save you some writing compared to what I did. If you're going into Math 60, don't do that. Keep doing it the long way, like I'm doing here. Why would that be? Because what would happen if this wasn't just a y, but was a y plus 1? Then that shortcut is actually choosing one path to go along. And I'm not going to pretend we're Math 60 and show you exactly why. But once I get to this step of y plus 1 times a number, I could either divide by 76 to get rid of that and have a y plus 1, or I could do what's called distributing. make this 76y plus 76. And in some problems, one of those will be a faster, easier way to go. And in other problems, the other choice would be the easier way to go. And if you're always doing it divided by 6, you're forcing yourself along one path that's sometimes not the right easy path. So for that reason, if you're doing algebra beyond this, then avoid that shortcut. It's a bad habit. If you were to write all the steps just to make a teacher happy, you don't have to write quite as much as this. I'm writing extra because I'm lecturing. So if I was to leave out this step, that would be fine. I could leave out that top black line. You could see I'm doing y times 76 divided by 76 is y. You could see I'm multiplying the two pink numbers and dividing by 76 to get that. So you could leave this out, and anyone reading your work could see exactly what you've done anyway. Similarly, I could leave out the orange step. If I leave out both of them, however, then it's just sort of, magic happens, right? How do I get from here to here? I'm not exactly sure. So I'm not a teacher that's going to grade you in this class about how you write things. If you were in Math 20, I would. But just as a habit, then yeah, you could leave out that, or you could leave out that, but don't leave out both of those middle steps if you're looking for making future math teachers happy. Okay, anything else about this one? Okay, and let's go back to here. Any other of these problems? 5. Okay, I need to translate this from an awkward English sentence to a nice equation. So a number, that'll be my y, minus 1/70th equals 1/7. Everyone okay with my translating step? So I have something attached to y with a minus 170. So I need to do the opposite. I'll add 170. And that will get y by itself. Again, now we're talking about penmanship, not necessarily arithmetic, but I don't want to try and write a bunch of stuff in this little space. That's going to break my nice flow of things going in an organized way. So I'll go off to the side and say, well, what is 1/7 plus 1/70th? Because that's what I'm trying to do on that side. Yeah.
So I know what the answer is, but I brained it, so I don't know how to put it.
If you could just write the answer, that's fine. That's okay. Okay, also as a matter of penmanship, I'm not going to squeeze my 1/7 and my plus too close together. I'm just used to leaving a little bit of space to the left of, or to the right of fractions so that if I need to reduce or unreduce them, I have a spot to do that. Because in this case I do. I need to do a times 10 top and bottom. Where did I get a times 10 from? The 70. I needed the denominators to match. Can't add without unmatching denominators. Once I had a times 10 on the bottom, I had no choice. I have to do a times 10 on the top. So again, I'm writing more than you would need to. You are no longer in Math 20. You don't have to be graded on how you write things. But there you go as a good example. Any questions about this before we take it off? getting to simple interest. Let's not do that yet. Here, hide that one. Okay. Any of those people want, or have we done enough review?
How would we set up problem number 12?
How do you say number 12? Okay, let's do that. So there's two ways to do this. I'm going to show you both because you could pick. If you were in a Math 20 class, you could pick which one you want, and that would be great. So they are percent sentences. So there's the translation method. We translated something a moment ago. We can do the same thing. Of means multiply, is means equals, what is the thing we don't know. So we could say 67% of what is 56. And I will just translate all of those. 67%, I can't put that in my calculator well, because calculator percent keys are unreliable. So what's the easy thing I do with percents? Decimal point. Do you want to come up and do this one? Sure, you've been waiting for a chance.
Okay, so we do the decimal point, and what do we do with the decimal point?
Move it over twice to the left.
Okay. And I like to remember that because there's 2 dots and a decimal sign. So you guys probably don't need that, but my memory's horrible. So, of. Okay. What? We'll do y. Stick with the trend. Is. Equals. And 56.
It's just 56.
Yep. So now how do we get y by itself? So y equals.
56 divided by 0.67.
Yep, because we divide this by 0.67. We divide this by 0.67. And if I can use your calculator.
Of course.
On button is so 56 divided by 0.67 equals 8358. So 67 of what is 56? 83.58. Does that sound?
Yeah, thank you.
Okay.
Okay, just as a curiosity, when I'm dividing both sides by something, I'll always use a little division symbol. It's perfectly fine to do what Edwin just did and make a fraction bar to show you're dividing, because they're the same thing. Anyone know why I don't use the fraction bar?
It doesn't flow as well in the columns, or I mean the rows.
It can be fine. It's because sometimes the numbers themselves are fractions. If the 0.67 was a 2/3, and so on like that, if I have fractions and then more fraction bars and so on, it eventually just looks sort of like totem poles, and it's hard to see what's a numerator and what's a denominator and so on. So that's what I do.
So can you rewrite that the way you would
Sure.
do? So,
If you like my handwriting, then it would. Oops, let me move it over. divided by 0.67 divided by 0.67. The y is whatever we had, 83.5. Okay, the other way to do this, besides translating, is the proportion method. And this method is pretty much only here because some people really like cross-multiplying. In Math 20, it's their favorite thing. They want to cross-multiply whenever possible. There are situations I have to warn them this isn't a cross-multiplying thing, and they try it anyway, and so on. So if you want to do this the proportion way, then you can. You start out writing fraction bar equals fraction bar, just like any proportion. Then, the right ratio you're going to use to represent the percent. It doesn't matter if it's right or left, really, but just so that when you're working with your neighbors, you're always having things look the same on the page, we just declare it that the right is the percent. So, we want it to be something over 100. This one is always 100. And this one is whatever our percent is. So in this case, 67. There's no ripple-up happening. No right into percent, left out of percent, scoot 2 times. Because 67 over 100 is percent with an over 100, rather than with changing it to a decimal. On the other side, there's going to be some number that follows the word of, just because you can't have an English phrase ending with of. Doesn't work. So whatever comes after of goes on the bottom. So in this case, of what? So that's what goes there. And then there's something that happens last. What number haven't I used yet? Or a y if I've used the numbers, and the what is the thing I haven't used yet. So in this case, the 56 is the thing I haven't used yet. To review, right bottom corner I put 100. It's always up. On the top I put whatever number had the percent by it. If the question said what percentage or what percent, then I would put the y there. I look for what happens after of. It goes in the bottom on the other side. And then there's something I haven't used yet. It goes in the last spot. Then I can cross multiply. Again, I'm writing more steps than you would ever need to. And I'll get the same answer. I guess this should technically be about equal because we did round. So if you like cross-multiplying, you can do the proportion method. There's no need to learn it. If the translate method is what you're used to because you've been translating math word problems all your life, then just keep doing that. But some people are fanatics with cross-multiplying, and there you go. Okay, questions about any of that? It's a complicated slide. Okay, so pick one, don't worry about the other one. Let's talk about bell curves. Get to Math 25. So last time we did typicality. Typicality was our introduction to when math needs to make up for the fact that real life is ambiguous. Just the word typical, the word average, sometimes we're not quite sure what that means. And so we have different types of math for different types of things. And we talked about histograms a little bit. And one of the most important things to look at was this page, because in histogram C, we can kind of see what a typical score is. It's about 50 or 60%. In histogram D, nothing really seemed typical, but nothing seemed especially untypical either, right? It still kind of makes sense to say the average is 50 or 60. In histogram A, the standard deviation is getting bigger, if you remember that word. And then there's like two groups. And now it's hard to say what typical means, because there's really two things we're talking about, not one, whatever it is we're measuring. And in histogram B, it was the worst. It was like these things were running away from being in the middle. So the only thing typical is not being in the middle. And so on. So to make up for this, we have different kinds of average. We had the mean, we had the median, we had the mode. And the mean and the median we use a lot, the mode we really don't. Okay. In the Factfulness book, the 6th chapter has many examples of when bins cause problems. Remember the two math score ones where this data set, which looks like nice A, B, C, D clumps, and this data set are actually exactly the same data. It's just the bins are different on the bottom of the histogram. These were more than twice as big, so by clumping students differently, the shape changes. So that can be a problem. More than just picking what bin size, then bins might hide the differences. If you say, what's the average income in a country, then there's not much ambiguity about what goes on the bottom axis. Each country is its own bin. But the question itself is kind of stupid, that countries often have very wide income discrepancy. So if there's no meaningful thing as an average income for a country, then it's not meaningful to compare them either. Bins might hide similarity. Bins might just measure averages of things. And if you're looking at a bunch of averages, then if the averages aren't too meaningful, then comparing them won't be meaningful. Bins might just measure majorities. Bins might measure something that doesn't have much meaning. Bins might make generalizations, or maybe the bins only have special cases, and so on. So just be careful of histograms. It's not that they are themselves bad, it's just that they are a tool that can make things look trustworthy, but there's no magic in the math that's making things trustworthy just because we make a nice picture. Okay, study skill, student success. Have we done this one yet? No, let's take a quick break, but not too long. Okay, what is success in math class? We talked earlier about pacing yourself and real life things coming to broadside you and so on. Success at LCC isn't necessarily about passing the class this term. Right? Jobs and kids and people getting sick and so on. Some people take 2 terms, and that's fine. It costs more money, but usually they wind up spending about the same number of hours. They just weren't able to actually make those hours happen in one term. So if being done this term isn't actual success, then what is? It's growing your critical thinking skills, learning to stand on your own 2 feet, and seeing yourself as belonging to a group, which, by the way, is another reason we're making food, because eating does something to our brains. It makes us feel bonded. So, critical thinking skills. I'm not going to talk too much about this. We have book reports in a math class, but there's really not that much about what makes a good discussion happen that we're doing. But look at this on your own. Think about critical thinking skills if you need to. Then the other things, learning to stand on your own 2 feet and seeing yourself as belonging. There's actually a word that does both of those, which is fascinating to me, because I don't know why. And my older boy is at Spencer Butte Middle School, and they changed their motto this year. Respect is no longer one of their key words. They've replaced it with dignity. And that was notable to me because people don't use the word dignity very much. But dignity is those 2 things. You have to be able to learn to stand on your own 2 feet. Standing is part of dignity in languages. And you have to see yourself as belonging. And whether it's celebratory or barely surviving, then if you're standing and you're belonging, then there's some dignity there. So you can read more about that out. This one I used to have in the syllabus, but I moved it. I'm not sure really where it goes. But just that we're not only here to respect people that get the right answers every time. Because if you already knew all the right answers, why are you in Math 25? Okay. Privilege we talked about when the trio guy came. Okay, bell curves. So bell curves used to be something that people would fight about a lot, because this fellow, Richard Herrnstein, wrote a book called The Bell Curve that talked all about IQ and made a big political stir. And I haven't heard much about it in recent years, so maybe that's faded away, or maybe it's just happening in a part of the society I'm not part of. But what is a bell curve? Histograms sometimes make one nice clump, and they're kind of shaped like a bell, so they're called bell curves. Their more formal name is a normal curve or a normal distribution. If you want to sound hoity-toity in a math division, then say normal distribution. But you can call them bell curves. That's what most people would call them on the streets. So bell curves, especially the nice balanced ones, the normal distributions, happen when being higher or lower than average is equally likely. And it's rarer to be very high or very low. So if we find the sum of 2 dice, this will make a bell curve. And with everything else happening this morning, I forgot my dice. I'll run to my office.
It might not work.
Okay, so come get 2 dice and check paper. Your job is to roll your dice a bunch of times and use a chart like this one to keep track of how many times each sum happens. I'm not going to worry right now about exactly how many times you roll them. Don't worry if it's the same as your neighbor. But just for a couple minutes, make a bunch of numbers. So I'm going to make tally marks on the screen once I call on people. Right, that kind of thing. But you can write it however you want.
Yeah, that's fine.
Anybody else want to spend the next 10 or 15 minutes after class studying and get a little picture, put it on the achievements? If we do that 3 times, so you're more than welcome to join in. We'll talk about whatever. Yeah.
But I know Courtney, she read over what I had, she's like, you find children with needs long, like, you're gonna be, and then I was missing with like the emotional piece.
Yeah.
Other than that, like,
Amanda?
it like
We're
tells
going
you
to next
all
time,
that.
15 minutes after class. If you have time to make a study group,
Case
if you want to join us and
No.
Oh, yeah.
And
you get one done, but we're going to do it today. And if you do 3 of them and take a picture, you get achievement and it is a chance to help you
It is.
writing behind.
Yeah, mine was totally a story. Like mine was,
Tuesdays and Thursdays,
yeah, I filled in so much extra information. It was,
yeah. And she just said that if I come out here that Wednesday, or whatever, that she'll be over here.
that's cool. She's good about stuff like that. Yeah.
This is my first term and I'm not taking English. Yet.
Oh.
Because all the guys have to take full. And so, I would have been very helpful to do that first.
Nice. Yeah.
Okay, let's pause and collect them all. So, if you rolled any 1s, you can't roll 1. If you got a 1, you're doing it. If you rolled any 2s, hold up how many fingers you got for how many 2s you rolled. Any 2s in the room? If you rolled 3s, hold up fingers for how many 3s you got. 1, 2, 3. So 3s, we have 1, 2, 3. Okay, 4s. You got 5 4s?
I got one.
1 4. Hold up one finger, then for 1 4. 1, 2, 3, 6, 7. 5s. How many 5s do we get? 2, 6, 9, 10. 6s. How many 6s did we get? 4, 5, 10, 11, 14.
That should be the biggest one, right?
7s. How many 7s did we get? 3, 4, 5, 6, 7, 8. Only 8. Okay. How many 8s? 2, 5, 9, 10, 14 again. It's going to be the same as that one. I'm being sloppy here. 9s. How many 9s? 2, 7, 8. So that's the same as that one. 10s. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that one's a little higher. 11s. 1, 2, 3, 4. And 12s. 2. Okay. So ours isn't a great bell curve. We're unusually low on 7s. It's not quite symmetrical, right and left. But the point to notice is that this one is more of a bell curve than what you have in front of you. And if we were to keep going, the more we repeat the random activity, the more the results look like a bell curve. So one thing we're learning is to have a good bell curve in real life, you need a lot of data. If you just have 20 students in a classroom or something, that's not enough. You need hundreds of data. Okay. So heights and weights are 2 natural physical characteristics of people that will form a bell curve if we get enough people and measure them. What else makes bell curves about people? Anyone know?
Hair color? income.
Oh,
I color your bell curve.
yeah, I'll show you. And it's interesting that for all the talk of bell curves that we have in our society, people don't just know this. So vision, nearsightedness and farsightedness compared to normal 20/20 vision in the bell curve. Bicep strength. If you have everyone do dumbbell curls, how much you can curl. Grip strength. And if your population is homogeneous, then blood pressure and life expectancy will turn out to be those. And that's really about it. If you search, then maybe you can find another, and I haven't, but I've looked a bit. And there just aren't that many things about people that naturally form a bell curve. Okay, here's two different bell curves. Because two bell curves here are supposed to, if my art is good, have the same area. There's the same number of people they're counting. But even though they're the same number of people, and even though their middle average value and mean is the same, then they're different shapes. What's happening is that more people in the blue curve are funky. There's more of them that are above the mean, more that are below the mean. It's not like either color has an exclusivity to somebody being a very high or a very low thing. It's just that on average, the pink curve is squished more towards the middle. More people are similar to each other in the pink. Does that make sense? We already have that vocabulary. The blue curve is more spread out. It has a bigger standard deviation. Okay. So here comes the interesting society part. So you've taken SAT tests and things like that. If you want to make a standard deviation, you can. You can repeatedly test a large group of people and alter the test and fidget here and there and make it so the results have a bell curve. So, if your main goal is to have the test scores turn into a bell curve, you can do that very well. You can have, again, many people take the test and do that. However, what you've been focusing on is making the shape of the bell curve. So if you look at the literature, I'm not going to follow the links here in class, but college entrance exams don't predict whether you're ready for college or will successfully get your degree. So they're very good at sorting people the way they're trying to sort people, but they can't also do that and predict college readiness. If you were somehow to be able to measure college readiness, and I'm not going to blame the SAT company for not doing that, because no one knows how to do that. But if you could, it wouldn't probably make a bell curve, because there's no reason to think that the biggest number of people are somehow median ready for college, whatever that would mean. So, wealth, income, education, all of those things, it doesn't tend to be true that those form bell curves. People expect them to. So this is a big case where people will design their experiments sloppy, because if they don't get a bell curve, they think they're doing something wrong. They might throw out good data and repeat a kind of different experiment with different things happening until they get a bell curve, and then they think they did it right. So just kind of be aware of that. Okay, here's the one that matters most at college. There's this phrase, grading on a curve. And most people, when they say they grade on a curve, they don't mean it. So let's talk about, since it's a math class, about bell curves, what it really does mean, and then what people mean instead when they use that. So it would make sense to say, I have a test, I've given it to a very large number of students, repeatedly from term to term. I know that the shape is a bell curve. Then I can assign scores where near the average would be the C, Slightly below or above would be the D or the D, and very far above or below would be the A or the F. And if I had done this enough, I'm going to use a nice color-coded one here, I could predict ahead of time how many students would be about here, and how many students would be about here, and how many students would be in the middle. And I was like the SAT company, and I've given a similar test to thousands and thousands of students. So even before anyone sat down this term to take the test, I could already know you need this score to get an A, or you need this score to get a B, or something like that. Does that make sense?
That'd be relevant. So if there was like 2 students on average that were just going to funk your class, you could look for the 3 students lower and see if it's worth your time to push them up and do it towards class. Or you could do a couple things like that. It's really interesting. Would that be a real life application of it to see what percentage is going to fail and then focus on that group?
Sort of. But the more important lesson is that none of this actually happens at LCC. None of our classes, none of our rooms are big enough to have enough students in them to make a good bell curve, just like we didn't roll the dice enough yet. And no one gives exactly or a very similar test term after term after term so that they can say, I know you need this score to get it this grade, even before anyone takes it this term, because they have such a well-informed track record. And most tests don't make bell curves anyway when you give them. If you just graph your data on a typical math test or whatever, it's not going to look like this. So, for all those reasons, what's happening at LCC isn't grading on a curve. The SAT is, because they have, again, many thousands of people on similar tests year after year, and they can say, if your score is whatever, 600 something, that means this, even before you sit down this year to take the test. But it doesn't work that way. So when people at LCC say they grade on a curve, they're not using it the right way. What they're usually meaning is that they sort of want a certain number, they want more B's and C's than they do A's and F's, and they're going to fidget with grades at the end of the term to try and make that happen. And if they don't think that there's enough A's, then they'll push some people up into A's or something like that. So it's usually some wishy-washy thing about fudging grade. But the take home for you is that if you see on a syllabus, I'm going to grade on a curve, you should ask your instructor what they mean by that. Because either they're going to try and assign you a letter grade before you take the test based on just a test score number, which they don't have the data set to do probably, or they're just fudgeting in some way, and it's your grade. You should know how they're going to fudge it with it before you sign up for the class. Okay. Check to see if you're paying attention. Here's a nice image from an interesting book about mental health. It's talking about stress. If you have way too much stress, you burn out. If you have a little too much, you feel overloaded but manage. If you have an okay amount of stress, that's motivating and keeps you going. And if you have too little, then you fall asleep. So they're trying to make a bell curve out of this, but this isn't, as it's drawn, a bell curve, even though the shape looks like a bell. So what's wrong with this? That is not a histogram, it's not a bell curve. What one word would need to be changed?
Bins are wrong shape. I don't know.
That's 4 bins.
Well, it's 4 bins, but the 2 center bins are smaller, so it's manipulating the amount.
That's okay.
That's not the issue.
That's not the issue. That's just art.
Performance.
Yes. Great job, Misha. So, histograms, including bell curves, have to count something. And performance is wishy-washy. I'm not sure what this is here that I'm counting. So, you could say this is a graph about a whole population and change performance to people. Some people are right now very stressed and burned out, and others are in these other bins. Or you could make this a histogram about a single person over time. In the past 5 years, I've had a few burnout days. Most of my days have been in the middle. And then that performance should say like days or something. Right? But whatever it is, the up and down axis needs to be something I can count.
Instead of just a blank line.
Yeah. So you can tell that what the author was trying to do. I'm not saying that their book is bad, but Okay. So, bell curve, I'm not going to read about that. Read that at home. The blame instinct is an interesting one. And that we've done already. So we finished. Your homework assignment, I printed for you. It is up on the website. The turn-in thing isn't yet. I still have to make that. But I was trying to figure out how to make homework about this, because all the stuff about SAT scores and stuff isn't numeric enough. So there you go. I hope this is interesting. And I think that's all. Any last questions? We have 1 minute.
When is food prep due?
But we didn't have any questions on it today, so a week from today. And we talked at the very beginning of class that if you want to start working on the big issue questions, you know enough stuff to do that now. You can start getting those done. A weekend's coming up. Good time to do book reports and big questions and things like that. Anyone need a book from my office to look at over the weekend?
Is anybody